Hi, so you're probably here because you came across my newsletter, you wanted to use OpenFOAM, maybe you got stuck along the way, maybe you've hit those common errors, or simply it's simply overwhelming. The truth is, engineering tools, especially open source tools, can be difficult to get your head around. As developers, we create tools like this for um, generalized use cases. So when you have a specific problem that you'd like to model or simulate, then it becomes a situation where actually there are so many tools available to you within this one tool that because it was designed, developed for a variety of use cases. So that's very important to keep in mind. The other thing to know, it takes a long time to get very good at these specific tools. Because they do so much, it can take a while to really understand how to use them effectively or efficiently. That's my experience anyway. That's what it's taught me. Ultimately, um, open source tools make it a little bit more difficult. It's a bit more difficult. The way around this is to consider the actual process or the workflow that you'd be following. I like to look at this in two different ways. There's the computational process, or what the solver expects when it comes to a CFD workflow. And then there's the engineering or research workflow, how you go about translating what you have initially, so your sketch, your ideas, your your use case, your physics. How do you go about translating what you have there over to what it needs to be before you can press solve? It is developing a workflow is really like muscle. You need to over you need to practice regularly, you need to overextend it periodically, and you need to do that so you can develop that muscle. And then, of course, over time, you grow in confidence because of that improved muscle memory you have developed. So, um, the thing about OpenFOAM, tools like OpenFOAM and CFD, what you want to really do is always start from the physics. And practically, that means constraining what you have in front of you, reducing that model complexity that you find in the physical world, and bringing it into the modeling, the digital side of the process. Only then, when you've got your variables mapped out, when you know what you're really looking to accomplish with these tools, then you can develop a plan of attack. What parameters are you going to need to put into the system? What does the solver expect? And then what do you expect to take out as a result? Okay, what do you need from this? You need the drag, you need the lift, for external aerodynamics. Do you need the surface wear rates? Do you need the combustion times? What do you need as an output from these specific tools? Okay, so I want to finally make you aware that I did create a user guide, a short user guide. It's only, I think it's 32 pages, so it's not very long. And the whole idea is to allow you to start using OpenFOAM with clarity. The whole way through, I take you from setting up a simple convection case in OpenFOAM, assuming no previous knowledge. I'll take you from that beginning stage through to the setup, the physics, the modeling, and developing and running your case, post-processing those results and retrieving an output using Parry. So I take you through the whole process of how to use it. There's no fluff. This is a pure physics-led simulation setup. And if you are interested in this, the link is in the description below. If you're not, no problem, but I would advise that you get yourself good resources to start. It can get overwhelming, it can be difficult, and many have stopped their journey, unfortunately, along the way. But I've personally had great feedback for this, and I hope to continue the series. If you liked this video and if you found it useful and if there was value in it for you, please do like it and subscribe to the channel. It helps us grow and it helps me reach more people that would potentially be benefiting from this content. So thank you very much for watching, and I'll see you in the next one.